Hello everyone, welcome back to the channel. Today we will be discussing the problem that is remove duplicate elements from sorted linked list. So let's get started. Our question is given a single linked list consisting of n nodes. The task is to remove duplicates from the given list if exist, and we would try to not use any extra space. Expected time complexity is order of n, and the nodes are arranged in a sorted way for this problem. So suppose our linked list is 2, 2, 4, 5. So what we are doing is we are removing this duplicate node and then returning 2, 4, 5. So in the given linked list 2, 2, 4, 5, as only 2 occurs more than one time listed here. So we are removing this 2 from the linked list. Now we can see another example. Now this is our linked list. So we need to remove the duplicates, and the duplicates would be here like 2 and 3. So we would be removing 2 from here and 3 from here, and our resulting linked list would be 1, 2, 3, and then 4. So I think you got a basic intuition of this. What we are doing is we are removing this next element, and instead of this next element we are pointing this to the next of next. So let's understand it, the code first, then we would be doing the dry run. So here is the C++ code for it. First, what we are doing is we are defining current as our head, and we are defining another node as pointer to. Now, if current is null, we would simply return it, as we need to return a node as shown in the function. Then, till current next is not equal to null means we are traversing the whole list. So in this case, if at any point the data of current becomes equal to the data of current next, what it means is the data of current, here current is 2 first and current next is also 2. So if this data becomes equal, as in this case, so our pointer 2 will be current next. So here the current next would be 4. So what we will do, we will assign pointer 2 to this. So this becomes our pointer and this is our current. So what we are doing is we will free up the current next, which means this one is freed up. And then we would point the current next to pointer 2. So this will be pointed to this. Next, again we will move to checking this condition. If current data is equal to current next data, which is now current would be shifted to here and pointer 2 will be here. So now current is 2 and current next is 4, and as we can see current data is not equal to the current next data, means 2 is not equal to 4. So this loop will not run, it will move to else condition and we would move current to the current next. So now current would be 4. Now current is 4, current data is not equal to current next data, so current would be moved to 5. Now current is 5 and current next would be null. Now 5 is not equal to null, so it will also move current to current next, and as soon as current next becomes null we would stop this. Hence our loop ended here itself and it would return output as 2, 4, 5. As we can see here, if I remove all this, so this is our final result. 2 is linked to 4 and then 4 is linked to 5. So our output would be 2, 4, 5 in this case. And so if current data equal to current next data, then we are assigning pointer to current next, freeing up current next so that we can remove that node and no extra space is occupied by that node because it is of no use now. And then current next is assigned to pointer 2, which is the current next, as we done from 2 to 4. And then if current data is not equal to current next data, then simply we are moving current to current next to traverse the whole list. At last, we would return the head of this list and we would get the sorted linked list without duplicates. So let's run this code and check. As we can see, the output is coming correct. Now let's try submitting this code. Hence, all the test cases passed successfully and the code is working fine. So let's take another example and test this code. We are taking 1, 2, 2, 3, 3, 4 as our linked list. Now, here what we do is we take this as our current node, which is 1, as head is a current node initially, and this would be the current next node. So moving on, we compare if data of this current node is equal to the current next data. We can see that 1 is not equal to 2. So we move to else condition where current equal to current next. So we move on to next of this current node. So now, as we can see, 2 is our current node and this is our current next. Now we compare the current data with current next data. So 2 is equal to 2. So we have pointer 2 as current next. So this will be our pointer 2. I'm marking it as P2. So this is our pointer 2 and this is our current. Now we free up current next, means we need to remove this current next from here. And we have current next equal to pointer 2. So our current next would be pointer 2 now. So this is our linked list for now. And then we have the current as the next one. As we compare 2 and 3 now. So 2 is not equal to 3. So in else condition, we have current equal to current next. So we move current to here. So the current pointer is here now. Now again, we check current data is equal to current next data or not. It is 2 here. So pointer 2 will be shifted to current next, which is 4. So pointer 2 is placed at 4, current is placed at 3. Now we free up current next. So the current next node is deleted and current next is pointed to pointer 2. So current next would be pointer 2. Now we check 3 is our current data and 4 is our current next data. 3 is not equal to 4. So we have current equal to current next directly as in else condition here. So what we do, we move this current to here. Now we can see that the current next is null. So this loop terminates. Hence we come to the end of the loop and this is our resulting list, which is 1, 2, 3, 4. So I hope this is clear now and you can now easily remove duplicate elements from sorted linked list. Hope you guys enjoyed this video. Thank you.